Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah, wa ala alihi wa sahbihi ajma'een. A'udhu billahi minash shaitanir rajim, bismillahir rahmanir rahim. Amma ba'd. Thank you very much for attending today's lecture. Today's lecture is on the understanding of solid depression angles and their role in determining the start of Isha and Fajr Salah in England. Now, as you know, in the last few years, there's been a heated debate regarding the times for Fajr and Isha. Most mosques have their own timetable. Some mosques do it an hour earlier, pray Fajr an hour earlier, some mosques an hour later, and there's general confusion amongst the masses as to why this is happening. This talk is a humble attempt to use astronomical data and bring to light why this happens, and it's for you, the general public, to make your own minds up as to what timetables you would like to follow. Okay, so from the beginning I'm going to start by defining the prayer times, and I know most of you know the times for Salah, but I need to do this to build up the issues regarding the different opinions regarding Salah times. So Fajr Salah, it starts from true dawn, as-subh sadiq, starts when the sun is 18 degrees below the horizon, and it's identified by a white light that spreads across the horizon. So if you're observing Fajr, you'd see the sky, you'd see the whiteness kind of appear and spread across the horizon. That's the time for Fajr. So it's important for establishing your suhoor. You need to make sure that you're praying, you've stopped eating at the right time, because if you don't, as you know, then you've eaten into the prohibited time to eat and you have no fast. Beware of false dawn, the zodiacal light. I'm going to get into this as we go on as to what this is. Now this is dawn. This is what dawn looks like. If you're observing the time for Fajr, you'd see the white light that would appear and then spread across the sky. And obviously as dawn carries on, as the sun gets closer to the horizon, you'd see a red light as well. Most of the sky at this point is still dark, especially the other side of you. It's still going to be black because the first crack of dawn appears on the other side, towards the east. That's a very early picture of, that's very early dawn. You know, it's just just happening. So you can see the whiteness of the sky. The rest of the sky is still black. You can still see the stars. That's the planet Venus on the ecliptic, and that's Orion. It's facing upside down. So there are two dawns. So we have a true dawn and we have a false dawn. Now many people, they see Fajr. I've actually seen this before as well, where if you are observing the time for Fajr, or if you're an astronomer, at various points during the year, it's towards the spring and winter equinoxes, especially in England. Most parts of the world, you can possibly see this every night if your skies are dark enough. You'll see what looks like the sun appear, but it's not the sun appear. It's an illusion. It's actually what's known as subh kazib. It's a false dawn. And now we're going to talk about that as we go on. So Fajr is not what appears in the sky like this, and also someone like that. It's what appears like this. So if you see a light appear like that, that's not. Be reassured, it's not Fajr. It's a phenomena, and it will disappear, and you'll have darkness again, and then Fajr will start soon. So Dhuhr begins once the sun has crossed the celestial meridian, true north, exactly halfway between sunrise and sunset. So you've got sunrise and sunset, the point midway in the middle. Once the sun is at its highest point and it's just crossed it, that's the time for Dhuhr to start. Now, that may not necessarily be at the highest point in the sky. Depending on where you are, that would only be at the highest point. It'd be directly overhead at the equator. Apart from that, nowhere else on Earth would it be directly overhead. So you can deduce that by looking at the shadows. When you don't have a shadow at the equator, or when you have the smallest shadow you can detect during the day, just after that point, sundowns will show you this. That's the time for your Dhuhr. So Asr, late afternoon, how to detect Asr started if you don't have a clock. The sun is cooler, yellower, and it's lower in the sky. There's a difference of opinion on when this starts. The Imam Malik, Imam Ahmad bin Hanbal, Imam Shafi'i say this is when the object of a shadow is 1 times its length. Now Imam Abu Hanifa says the shadow needs to be twice its length. So you've got a stick in the ground, and the shadow of the stick is this much at noon. So what you do is you add on another shadow length of the object. That will give you the time for Dhuhr. According to Imam Abu Hanifa, 2 shadow lengths. take into account the original shadow. It's important that you take into account the original shadow length at dawn. So Maghrib starts when the solar disk is completely below the horizon. It's important due to prayer and breaking fast, because you need to know when Maghrib is. Most timetables for Maghrib, by the way, give you elevation levels of at sea level. Now most cities are higher than sea level, so we need to factor in that and add a few minutes. So we'll talk about that as well. Comes back to optical actual sunset sightings. Most time, I should talk about that as we go on. So lasts until astronomical twilight. So Maghrib time will last until the time for Isha, which is when astronomical twilight totally disappears and you have complete darkness. Now that varies season to season, latitude to latitude. Isha time, again there's a difference of opinion, starts when the whiteness of the sky disappears. This is the opinion of Imam Abu Hanifa. So the whiteness is the last light to disappear when it's 18 degrees below the horizon. When the redness of the sky disappears, this is the opinion of the Sahibain, Abu Yusuf and Muhammad ibn al-Hasan. The solar disk, 18 degrees below the horizon again. Yeah, it's the difference of opinion. Safer to follow the 18 degrees, especially for northern climes like England, Canada, America, Russia, and we're going to talk about why it's more safer to follow the 18-degree solar depression angle. Okay, so if this is a 24-hour clock, this is night time. That's when the sun is 18 degrees below the horizon, and this is when twilight starts. This is when dawn, the crack of dawn, starts, and it carries on until the sun's solar disk pops above the horizon, and then that's it. You can't pray Fajr no more. That's at its highest point. Just past its highest point is Dhuhr, and then again mid-afternoon, Asr, and then when the sun's solar disk completely disappears below the horizon, Isha, and then you get twilight, Maghrib, and then you get twilight, and then you have Isha. So how is the time for Fajr determined? We have an ayah of the Quran. And eat and drink until the white thread of dawn appears to you distinct from the black thread, darkness of night, then complete your sawm. So the black thread, the black thread of darkness from the white thread of dawn. So as you get first light of khalas, and you get the light spreading across the atmosphere, that's the time of Fajr. So it's visible at the crack of dawn. So that time is visible at the crack of dawn, and a white light that appears ghalas and spreads across the horizon is far. The Prophet ﷺ said the time for the morning prayer is from the rising of dawn until sunrise. So twilight. So why is twilight important? Twilight is the time when your sun goes below the horizon until complete darkness, and when from the crack of dawn till the sun shows itself above the horizon, that's the time that's twilight. It's neither completely lit, nor is it completely dark. The sun itself is not directly visible because obviously it's below the horizon. Let's drink some water. All right, if we didn't have an atmosphere on the earth would be completely dark. The minute the sun went below the horizon, you'd get complete darkness, like it is on the moon. It's because we've got an atmosphere that even though the sun is below the horizon, the light is still hitting the atmosphere and it's being refracted and reflected and scattered across parts of the earth still for some time. So that's the reason why you still see twilight when the sun's gone down. Twilights are very beautiful, as you know, and straight after sunset, the sun's about to go down, the sky becomes red. And as twilight descends, as the sun's solar angle depresses further and further below the horizon, that changes to white, and ultimately it'll disappear. So what time does this happen? This is where the problem lies. There's many definitions of twilight. There's civil twilight, when the sun is 6 degrees below the horizon, nautical twilight, 12 degrees, and astronomical twilight at 18. So here's the horizon, here's the sun. So from here to here, 6 degrees is known as civil twilight. This is the time when in England, by law, they switch on the street lights. And half an hour after the sun goes down, they start to lock the parks and public places. And once the street lights come on, it gets darker than it normally should be anyway. But you can make out a few stars, it's getting dark. From 6 degrees to 18 degrees nautical twilight. Now, Just at the end of nautical twilight, this is when seamen stop observing the horizon and taking measurements, because they can't differentiate the horizon from the sky anymore. So it's kind of dark, it's very dark now. But the last part of the light is still visible in the sky. And if you are in a truly dark place, you'd see that the sky is actually this color. Moving on to black now. And that's from 12 to 18. And total darkness, I think when it's the lux levels are 0.00006, is when it's complete darkness. And one really surefire way of working out if it is complete darkness without having a clock is to observe. If you know your constellations, you know your objects in the sky. Now the very faint objects will not be visible until the sun is 18 degrees below the horizon. So if you can't make them out and you are in a dark sky, then you know that it's not Fajr, and you've got to wait till you can see them clearly to know Isha, that you know that it's Isha. Okay, so here's the angle of the sun from the horizon, the light levels, and 15 degrees it's more or less dark. And then you carry on to 18 degrees, and at 18 degrees it really gets dark. So twilight. So what twilight do we follow for Fajr and Isha? Most Islamic astronomers and academics agree in twilight being 18 degrees below the horizon. Abu Hanifa advocated 18. The two Imams advocated 15. Now, 15 degrees between 12.5 and 16 is where you get the red twilight, Shafaq al-Ahmar. Now, once the redness disappears, according to the Imams, you can pray. But Imam Abu Hanifa says, no, it's 18 degrees, we have to wait till the white disappears as well. In England, we follow the 18 degrees, and I'm going to tell you why we do that. It's not something new, it's something that's been in existence for 1,000 years. And the ulama in the past used it, our astronomers used it. And here's a chart of all the astronomers, polymaths and academics that advocated 18 degrees and above. Very famous names like Al-Batani, As-Sufi, Biruni. 18 for Fajr, and actually some of them go down to 19 and 20. So if you think 18 degrees is dark still, then what light are they seeing? And then Isha again, 18 degrees, 17 degrees, 19, and 1 or 2, 16. So it's more important to worry about your Fajr than it is Isha, because from the ayah in the Quran. So you can see that nobody advocated solid depression angles of less than 18 degrees below horizon. So Allama Shami rahmatullahi alayhi advocates 18 to 19 degrees as the time for Subh Sadiq in his celebrated book Rad al-Mukhtar. Allah Hazrat Ahmad Raza Khan rahmatullahi alayhi in his Fatawa Rizviya, and this is a whole book he's written on the phenomenon of Subh Sadiq, on this issue of solid depression angles and twilight. And Maulana Ashraf Ali Thanvi in his Imdadul Fatawa, again 18 degrees. And Sheikh bin Baz of Saudi Arabia, along with Sheikh Fawzan and the shura they have. In one of their decrees in the Muslim World Degree Center, 19 Rabi 1406, they said Fajr corresponds to when the sun is 18 degrees below the eastern horizon. So Imam Abu Hanifa rahmatullahi, Subh Sadiq and Dusk Shafaq, these two occur at the same time when the sun is 18 degrees below the horizon. Abu Rayyan al-Biruni, a very famous Islamic astronomer, polymath, he writes again when the sun is 18 degrees below the horizon. Mufti Azam Baghdad, Allama Muhammad al-Usi, again 18 degrees. And in 1983 in England, we had a convention, because in England, as you know, we don't get, it's very cloudy for many months of the year. Most of the year actually, especially up north, it's cloudy. We can't detect Fajr times properly, or Isha times, or moon times for that reason. So we've always been shrouded in controversy, and we've had problems from the beginning regarding moon sighting and regarding Salah times. Why? Because most of our skies are always cloudy. So in 1983 we had an agreement, the ulama had an agreement where they all agreed that we were going to agree. Some of the most senior ulama in England were there, and from India and Pakistan, and it said that Subh Sadiq is when the solid depression angle is 18 degrees below the horizon, and likewise for Fajr, for Isha as well, when the sun goes down. So Sayyidina Aisha, this is a very interesting hadith to understand. So Sayyidina Aisha says, we the Muslim women would attend the morning prayer behind the Prophet ﷺ with our bodies covered in sheets. After the prayer, when we would return home, due to the darkness, al-ghalas, the word used, very important, we could not recognize each other. Hafiz Ibn Hajar al-Asqalani writes, due to the darkness we could not recognize each other means due to the darkness they could distinguish the form of a body but not recognize whether it was Khadija or Zainab. Now, being in Saudi Arabia, you know that they're very generous with their salah times. Isha can be from anything from 15 to 20 minutes, Fajr, from 15 to 20 minutes long. Now, if they pray on the crack of dawn or straight afterwards, now when you go into prayer and you come out, it's still dark. At the time of Rasulullah ﷺ, the prayer must have been a bit more generous, right? We know from hadith that do not prolong your Fajr prayer too much, but compared to the other prayers, it's longer than our prayers is today. Now they would pray and they would come out, and even after praying the prophetic prayer and coming out, they could see each other, they could see the silhouettes, because it's possible to see a silhouette in darkness, because the sky behind you is always going to be brighter. Even when the sky is totally black, it's going to be brighter than it is normally. But they would not be able to recognize the faces. So this is very interesting, because even after that lengthy prayer time, they could not recognize each other's faces, meaning the sun was very low down below the horizon. And it was still low down below the horizon when they came out. Now that could never happen if, like England, some prayer times put the sun at 12 degrees, nautical twilight, or 15 degrees. This had to be 18 degrees. So al-ghalas is translated as the last part of the darkness of the night that separates, which is joined to the first light of the day. So the darkness joined to the day, that distinct moment, ghalas. And it has to be dark. Yeah, it has to be, it has to be completely dark when you're seeing that. So Dr. Ilyas is a famous Islamic astronomer and scientist from Malaysia. He's got a very famous book called Islamic Astronomy for the 21st Century, something whereabouts. And even he mentions, without reading the whole thing, that in modern times astronomical twilight has come to me. So they understand that it's astro-astronomical twilight. So the phenomena, astronomers acknowledge that, because the only people that are really concerned with 18 degrees solar depression angles are astronomers, because it affects their sightings of celestial objects. And the only other people that are concerned are ourselves. So even they understand that they've given it the term astro-Islamic twilight. Indeed, 18 degrees solar depression was a commonly used value for Fajr and Isha in the medieval period, when it was based on careful observations. Nevertheless, slight variations, again, variations from 16 to 20 have been observed. But for twilight, the variations are, as I'll prove to you, it's from 17.5 to 19.5. The 16 degrees is not astronomical twilight, but you're moving back, you're moving earlier for your Isha times. Whereas 19 degrees and 17 degrees were the parameters, as I mentioned. It's the 19th for the Fajr, the Fajr, and the 17 for Isha. Astronomy of Islamic Times for the 21st Century. That's the name of the book. Right. This was an experiment that was conducted by scientists in Malaysia 4 years ago. It's from the International Journal of Applied Physics and Mathematics. Now over here, they're giving you the time, and they're giving you the altitude of the sun, and they're giving you these are light quality testers. They tell you how dark the sky is in the sky. So SQM meters and the altitude of the sun. So even when the sun is 18 degrees below the horizon, it's still registering light. You can see that it's still registering some light in the sky. And this was calibrated within the parameters of the human eye. So this is basically, it's not a very superfine instrument that's picking out light that you and I cannot see. It's calibrated to the same parameters as the eye sees. So what this is seeing is what the eye technically can see. Now again, if we look here, this is the horizon, 0 degrees. So the sun is gone down. This is the time for Maghrib, official time for Maghrib. And as the sun moves down the horizon, 10 degrees, 15 degrees, 20 degrees. See, this is the disappearance of Shafaq Abiyad. So this is the disappearance of white twilight. At what degree is that? It's looking like it's 19. It's very close to 20. This is the time, official start time for Isha. So we start Isha about 2-3 minutes afterwards. But they proved that it's 18 degrees and beyond where you get complete darkness in the sky. So various organizations in the world. We have the University of Islamic Sciences in Karachi, 18 degrees for Fajr and 18 for Isha. That's followed by Pakistan, India, Bangladesh, Afghanistan, parts of Europe. ISNA, 18 degrees for the USA and parts of Europe. Muslim World League, 18 degrees and 17 degrees for Fajr. Europe, Far East Asia, parts of the USA. Al-Qura University in Mecca, 19 degrees and 90 minutes after Maghrib and 1:20 during Ramadan. I suspect the 1:20 is to give people more time to get into the mosque for Isha. This is in the Arabian Peninsula. And the Egyptian General Organization of Surveying, 19.5 and 17.5 respectively. So they're actually playing it safe, or they've got the data on hand that proves that even up to 19 or 19.5, as we proved from the previous scientific study, that it's still technically Shafaq al-Abiyad, the white twilight is still visible. Not to you and I in cities, but out in the country or above the sea, it's still visible. So persistent twilight, what if the sun does not set low enough to ever go back? Sorry, just one thing here. You know the Al-Fajr Islamic clocks you have, or any Islamic clock you get, or the watches you get? If you look in the instruction manual, or even in Salah times, if you were to go to the internet and find a prayer timetable, and it would have, you can actually choose your solar depression angle, or you can choose which university you want to align yourself with. So depending on the university, this would actually give you the times for prayer times according to the angle of the sun below the horizon. I used to choose University of Islamic Sciences, Karachi, but now I just like to put 18 in. Persistent twilight. What if the sun does not set low enough for the sky to ever be black? What is the ruling on prayer and fasting? What happens to the night prayer, tahajjud, and God's mercy? Now, in England, in the summer months, from the 21st of May till the 20th of July, we have what's known as persistent twilight. This is where the sun doesn't descend 18 degrees below the horizon. So technically, it's not dark. If it's not dark, how can you pray Fajr, and then how can you pray Isha, and how can you pray Fajr in the morning? Because to pray Fajr, it needs to be complete dark, and then the darkness needs to separate, the whiteness needs to separate, and that's Fajr. So many events, we know that in the last part of the night, the mercy of Allah subhanahu wa ta'ala descends, and He descends to the lowest part of the heavens and says, ask of me and I shall give you. Who is there to seek refuge in me? So if that doesn't happen, does this still happen? Laylatul Qadr, starts after Maghrib up to Fajr. And the tahajjud, your tahajjud prayers. So what happens? Do they still happen? Do they not happen? Rest assured they do happen, and I'll explain to you how. So from latitude 48, which is somewhere in France, and above, which is, if you know where France is in the world, that latitude, I think it's midpoint, just below France. Latitude 48 and above, the sun never descends 18 degrees below the horizon for some parts of the year. Now London is at 51 degrees 34 seconds, or is it minutes? 51 degrees. From the 22nd of May till the 20th of July 2012, in London, the sun will not descend 18 degrees below the horizon, which means you've got perpetual twilight. You've got a problem with your Fajr and Isha times now. Bradford is north, higher up. It's at 53 degrees. So from the 12th of May till the 31st of July, so it's even more days. The 22nd and the 12th. And it's longer this way as well. So how does this happen? Well, basically, the Earth rotates around the Sun in 365.25 days. That's approximately 5 hours, 48 minutes, and however many seconds. Now, we've always been told it's 365 days. It is. But it's actually a bit more than that. It's 5 hours more than that. And it's important to know this because you'll find out when we work out the prayer timetables why it's important to know it's actually 5 hours and not just 365 days. It also rotates around its own axis every 24 hours. So not only is the Earth, let me show you here. So this is the Earth. So it's rotating once on its own axis in 24 hours. Yeah? So you have a day and a night in 24 hours. And also it's rotating once every 365 days around the sun. So every 365 days, it does one complete rotation, one orbit around the sun, and once every 24 hours, it does a rotation on itself. So the Earth, it's got a tilt of 23.5 degrees. So as you can see, the Earth is not straight. It's not like this. It's actually tilted 23.5 degrees. Now, this is what gives us the seasons. I'll explain to you now. So when the northern hemisphere is tilted towards the sun, we get long days with short nights. And when it's the southern hemisphere is tilted, we in the north are going to get shorter days and longer nights, and they're going to get longer days and shorter nights. I'll explain to you. Right, London, 51 degrees. That's where we are. So anything above 48, which is going to be about here. Yeah, it's halfway through France. 51 degrees and above, you get, well, from 48 degrees and above. So at the 48th parallel and just above, you're going to get one day in the year where you're not going to get perpetual darkness. You're going to get one day of twilight. As you move up, you're going to get 2 days, 3 days, 4 days, 5 days, and it carries on. When you get to England, you get 2 months, and as you carry on, Scotland 3 months, and you carry on past the Arctic Circle, and when you get to the North Pole, you get 6 months of perpetual daylight where the sun doesn't descend below the horizon, and in the winter you get 6 months of darkness where the sun never rises above the horizon. So the Muslims in Norway, Sweden, Denmark have a big problem. If you think we've got it bad in England in the summer, what do those poor guys do? Right, so this is the axial tilt of the Earth. So the Earth is tilted 23.5 degrees. It rotates once around itself. This is the ecliptic. This is where the sun is. The sun and all the planets are on the ecliptic. But we are not aligned. From the horizon, you wouldn't be aligned directly to the ecliptic. You'd be up. Your horizon, your celestial equator would be above you. So you can technically see that from any point in the world. So, okay, do you remember, right now I mentioned the northern hemisphere, southern hemisphere. So here, okay, imagine this is the sun. Okay, imagine the sun's hitting us here. So now this is the Earth, this is its angle, and this is how the Earth goes around the sun. So if the sun's over here and the sun's hitting directly here, you can see that the part that's getting the light is this part here. Yeah, the top, it's being deflected. Yeah, so the sun is hitting full on in the southern hemisphere. So you're going to get long days and short nights, whereas here you're going to get a very short